Okay, we'll take a look through the Dynamics Quiz 1. We have two cars traveling here. So we have car A and car B. We see here that car B is traveling a distance d ahead of car A. There we are. At first they're both traveling at 60 feet per second. Driver B suddenly applies the brakes. Her deceleration is 12 feet per second squared. Driver A takes 3/4 of a second to react, and then when they brake, the second driver of car A decelerates faster at 15 feet per second. We're asked to find the minimum following distance d to avoid a collision. Alright, and then there's a little rubric, so we get velocity equations, position equations for both vehicles. We get 2 points each, and then solving for d we get our final 2 points for the 10 points. So if we take a look here, our approach, I'm going to do step 1, coordinate system. Step 2, write equations for VA, VB, SA, SB. Find the time with closest position. And finally, 4, determine the following distance. Alright, so coordinate system, I'm going to take the beginning of car A here as s equals 0. That'll be my coordinate system, and I'll have s positive going to the right. Scroll down a little bit here. So step 2, equations. So the velocity of B is a little easier to do, so we'll do that one first. Our initial velocity, 60 feet per second, plus our acceleration times our time. We have constant acceleration, so we can use that equation. So we're going to have plus negative 12 feet per second squared times time. So that equation gets us 2 points. Our velocity of A is a little more challenging. We have 60, and then we have minus 15. And then the time here, we have a delay of 3/4 of a second, so we're going to have t minus 0.75. So I'm using the same time scale. This just means I don't start slowing down until 3/4 of a second after person B puts on their brakes. So that gets us 2 points. Position equations, SB. So what do we have at first? They have an initial position of D plus D plus 60 times time plus 1/2 AT squared. Why does my D keep going away? There's D. So it's going to have negative 6 1/2 of my A T squared. That gets me 2 points. SA. We're going to have our initial velocity, our initial position is 0. Then we're going to have 60 feet per second times t. We don't start slowing down immediately, so I'm going to leave that there. And then we're going to have minus 7.5. And here we're going to have t minus 0.75 squared. So that acceleration doesn't kick in until time is at least 0.75 seconds, and then it's that 15 feet per second squared rate. So there's our other 2 points. So that gets us our main 4 points. Now I'm going to draw on the other side here. So just conceptually, this is velocity, this is time. At first we have, when B starts going, there's VB. A starts with the same, why am I losing that? Okay, there's VB. Here's A, and then he slows down faster. So potentially he's going to stop shorter. So really what the area that we're concerned about is when these are at the same velocity. So that's going to be what we solve for, and then we'll use that time value in our position equation. So step 3, set VA equal to VB, solve for time. So we have 60 minus 15 t minus 0.75. Some of you may have carried that through and had minus 15t plus some amount. That would have been fine as well. Equals 60 minus 12t. So it's pretty clear. Our 60s will cancel out. We'll have negative 15t on this side plus the 15 times that. I think that's 11.25. It's negative 12t. So I'll pull this 15 to the other side, so I get t equals 11.25 over 3. T, when the velocities are equal, is 3.75 seconds. You didn't get any points for that, but you needed it to find D. I weighted it this way to hopefully encourage people to remember these equations versus getting the correct answer. And if you get the correct answer, you get some more points. So then finally, we'll solve for D. So what are the two positions at that time? So SB is D plus 60 times 3.75 minus 6 times 3.75 squared equals SA, which is 60 times 3.75 minus 7.5 t minus 0.75 squared. So these parts cancel. If we carry that through, find D. Oh, that was 3.75. Sorry. So this whole thing under there becomes 3. So D equals 157.5 minus 140.625. So that means that car A has traveled this distance in that 3.75 seconds, while car B only traveled this distance. This means that our following distance at the beginning to avoid a collision at 3 3/4 seconds needs to be 16.875 feet. To 3 significant figures, 16.9 feet. And in this case, we had to round up, which is good. We wouldn't have wanted to round that down. That would have meant we had some collision of some distance, inch and a half or whatever, in that 1/8 of a foot. So there's our answer. So we get our two points there. So hopefully that clears things up as far as how to solve that quiz problem. The main key there was setting up the position equation and velocity equation for A with that time delay, making sure you had the same coordinate system, and then realizing that the time of a collision would have happened when those velocities were equal. That's it would not necessarily happen at the end of the time. I think some people solved for how far apart the cars would be at the end if they avoided a collision, which is another interesting thing, although may or may not result in having a collision midway through.